Hello everyone, and thank you for joining us today. I am Joel. Joining me is Arya, Hope, Nidhin and Tess, each bringing valuable insights and expertise that have shaped this presentation. This presentation explores Tesla's high-impact strategic decision to expand its global manufacturing through the establishment of Giga factories in Shanghai, China and Berlin, Germany. Let's move into the presentation. Tesla's expansion into gigafactories in Shanghai, China in 2019 and Berlin, Germany in 2022 represents strategic maneuvers to bolster its global manufacturing capabilities, reduce logistical complexities, and cater to regional markets more effectively. This move is the first time Tesla has built factories outside of its home base in the USA at a time when Tesla faced increasing global demand for its electric vehicles, coupled with cost pressures and logistical challenges. The main objectives behind this decision were threefold: to increase global EV production capacity and reduce delivery lead times, to localize manufacturing in China and Europe, Tesla's fastest growing market and policy-driven markets. In addition, situating manufacturers closer to key markets, Tesla can mitigate tariffs, reduce shipping costs, and respond more swiftly to regional market dynamics. And to deepen vertical integration, gaining more control over battery production, supply chains, and overall manufacturing. This decision was also aligned with the broader EV adoption trends and favourable government policies in both China and the EU, making it a timely and future-proof strategic move. To assess Tesla's internal capabilities, we use the Vero framework and Porter's value chain. Tesla benefits from strong brand recognition and is widely regarded as a leader in the EV market. It holds proprietary battery and drive unit technologies, delivering energy efficiency and product differentiation. Its scalable software and full self-driving platform enhance innovation and profitability. A key strategic strength is Tesla's high level of vertical integration, from battery cell integration to direct sales, which reduces supply dependency and boosts agility. Factory automation further supports quality and production consistency. Tesla operates more as a founder-led organization, with CEO actions sometimes negatively impacting public and investor sentiment. Its reliance on scarce raw materials like lithium and cobalt presents long-term supply risks. The service network remains underdeveloped, limiting post-sale support. While efficient, Tesla's production processes are costly and becoming more complex with global expansion. Adapting to various regulations in new markets also presents ongoing challenges. Over now to Nidhin.
Thanks, Joe. This slide covers Tesla's external strategic analysis using the PESTEL framework. Tesla's expansion into China and Germany is shaped by several macro environmental factors. Political. Both governments support EVs through policies and subsidies. Economic. Local production helps avoid tariffs and meet rising demand. Social, consumers increasingly prefer sustainable transport. Technological, these countries offer advanced manufacturing ecosystems. Environmental, strict emission laws align with Tesla's clean energy goals. Legal, while regulations are complex, compliance boosts Tesla's legitimacy. Overall, PESTEL shows a favorable environment for Tesla's global growth through localized production. Now let's explore how industry-specific forces shape Tesla's strategy using Porter's 5 forces. This slide analyzes the competitive dynamics Tesla faces. Rivalry is high, with the traditional automakers and new EV brands competing aggressively. Threat of new entrants is moderate, EV demand is rising, but high capital and tech requirements act as barriers. Supplier power is significant due to key materials like lithium, though Tesla offsets this via vertical integration. Buyer power is growing, but Tesla's brand and innovation help retain loyalty. Substitute threat exists like hybrid and public transport, but Tesla's value proposition still leads. In summary, the EV industry is fiercely competitive, but Tesla is strategically positioned to stay ahead. Here is a quick snapshot of Tesla's competitive position. Tesla leads in technology, especially with its battery innovations and full self-driving capabilities. Its gigafactories drive cost leadership, cutting per vehicle cost by up to 25%. The brand remains dominant in the premium EV space. However, the competitors like BYD in China and Volkswagen in Europe are gaining ground with scale and strong local trust. Tesla's edge lies in rapid innovation, efficient scaling, and smart localization enabled by its modular gigafactory model. Together, these external insights show that Tesla's localization in China and Germany is not just about meeting demand, it's a strategic move shaped by macro trends and competitive forces. Next, we will look at how Tesla turns this strategy into scalable execution. Over to Hope.
Thanks, Nidhin. Tesla's factory as a product approach underpins the success of its gigafactories in China and Germany. Instead of designing each site from scratch, Tesla deploys a modular blueprint, a scalable, repeatable factory model that cuts construction time, complexity, and cost. Lessons from Gigafactory Shanghai directly informed the faster rollout of Berlin, creating a global feedback loop that accelerates learning and execution. This approach allows for regional customization, regulatory alignment, local labour integration, and tailored logistics without losing consistency or control. The result is a globally agile production network that aligns with Tesla's innovation goals while supporting fast market entry and sustained cost advantage. Tesla's vertical integration is central to scaling its global operations efficiently while driving innovation. By internalising battery production, including its 4680 cells, and deploying GigaPress technology, Tesla reduces part complexity, boosts manufacturing speed, and protects proprietary tech. These integrated capabilities streamline operations and reduce supplier risk. AI and machine learning further enhance forecasting and adaptive production planning across sites. Tesla's direct-to-consumer model also reinforces control over branding, pricing, and consumer experience. Together, these elements form a tightly coordinated system that fuels innovation, lowers costs, and secures Tesla's competitive edge in the EV market. And next we have Arya discussing outcomes, KPIs, value, and advantage. Thank you.
Thanks, Hope. Tesla's Gigafactory strategy has delivered high-impact results, particularly in Shanghai and Berlin. Shanghai now produces over 950,000 vehicles per year, with more than 3 million vehicles built since 2019. It's also Tesla's most automated facility, running at 95% automation, and turns out a vehicle in just 40 seconds. The production cost there averages about $32,600 USD per unit, significantly lower than the US levels. And importantly, over 1 million of these vehicles have been exported globally, making Shanghai a core logistic and export hub. Berlin, which launched in 2022, now produces over 300,000 vehicles annually and recently surpassed 500,000 units produced in total as of April 2025. Across both plants, Tesla has achieved over 25% unit cost reduction through vertical integration and standardized modular factory design. This supports fast scaling, localized responsiveness, and helps maintain 20% gross margin, well above industry average of 16%. Despite impressive performance, both factories faced major challenges. Berlin has faced environmental backlash on tree clearance and groundwater usage concerns. Other major challenges include Germany's complex regulations, significant union pushback, and community resistance. Shanghai has had to navigate strict regulations as first foreign-owned automaker, deal with supply chain risk with lithium cobalt dependency, and manage the US-China geopolitical tensions. Tesla has responded to these challenges with environmental offsets in Berlin, localized supplier and vertical integration to reduce risk, decentralized the teams for faster regional decisions, and maintained direct employee engagement. These actions help Tesla stay agile and profitable. Now I'll hand over to Tess for strategic models and recommendations.
Thanks, Arya. Tesla operates at the intersection of major global forces. Through a pestle lens, we can see the company navigating tightening environmental regulations, shifting trade dynamics, and exponential tech change. Their approach reflects both compliance and leadership, shaping markets rather than just reacting to them. Social expectations around sustainability and clean energy are core to their positioning. At the same time, legal factors like data protection and EV subsidies create both barriers and levers across regions. Based on our evaluation, Tesla should continue to expand its Gigafactory blueprint into emerging markets like India and Mexico to capitalise on early demand and cost advantages. It should co-develop local supplier ecosystems to improve resilience against geopolitical shocks. Tesla must also deepen its environmental, social and governance alignment, especially in regions with regulatory complexity like EU, to maintain stakeholder trust and secure operational licenses. Lastly, decision-making should be decentralised, enabling regional executive to lead with cultural sensitivity and agility. These recommendations are aimed at scaling Tesla's global footprint while protecting its innovative core. Across our analysis, the Ansloff matrix emerged as a shared frame. Tesla is executing all four growth strategies, deepening current markets, entering new ones, innovating with products like the Cybertruck, and diversifying into energy and AI. The insight here is not just strategic ambition, but strategic coherence. Every move is calculated to build sustainable advantage. Ultimately, Tesla's strategy shows us that success lies in combining foresight, structure, and bold action backed by frameworks, not guessworks. Thank you for listening to our presentation.